Welcome to the deep dive. Today we're cutting through the headlines to look at something pretty ambitious out of Japan.
Very ambitious.
Yeah.
We're talking about the Japan Science and Technology Agency's uh, Moonshot initiative.
Right. And we're going to focus on one specific goal, goal number 3, which is this mandate to create a world by 2050 where AI-powered robots are just a part of everyday life.
Yeah, and it's so important to get the context here. This isn't just tech for tech's sake. It's driven by a real social need.
Japan's aging population.
Exactly, a rapidly rising elderly population.
Oh.
So these robots are being designed to, fill a huge gap in senior care. We're talking cooking, cleaning, even really personal hygiene care.
And the main robot we're looking at today, the one sort of leading the charge, is the AI-driven robot for Embrace and Care, ARE for short.
That's the one.
So let's talk about how it's built. I mean, the development speed here was really accelerated by using NVIDIA's AI and robotics platform.
It was. They had this really smart split architecture. The main mobile robot, they call it dry AIREC, has 2 powerful NVIDIA GPUs right on board.
For all the heavy real-time thinking, right?
Exactly, for the complex decision-making, figuring out how to move, how much force to apply in the moment.
And what about the other model, the AIREC Basic?
So that's more for data collection. It uses 3 NVIDIA Jetson or an NX modules. That's all about efficient processing right there at the edge where it's gathering the data.
So it learns on the basic model, and then that knowledge gets transferred over to the mobile dry air.
You've got it. It builds this incredibly rich model of human movement first.
Okay, so that's the hardware. But hardware needs training. And what I found fascinating is they didn't just use the real world. They used NVIDIA Isaac Sim.
A huge virtual training ground, essentially.
But how does practice in a simulation translate to, carefully handling a fragile human being?
Well, that's the key. Isaac Sim lets them run millions of scenarios without ever putting a person at risk. They can simulate calculating the wrong force or a bad trajectory. It brings to mind what Professor Ogata said.
Oh, what was that?
That just 5 years ago, before generative AI really took off, hardly anyone thought this was even possible. The whole atmosphere has changed so quickly.
So was it the generative AI that unlocked this? The ability to model force or to generalize movement?
It was the combination of both, really. It lets the robot take a limited set of data from human caregivers and then generalize it to almost any body type or situation it might encounter.
Okay, let's pivot from the tech to a really specific human challenge, patient repositioning. It's vital for preventing bed sores, helping with diaper changes. It's also incredibly difficult to automate.
It's an intensely complex problem. Misa Matsumura's research really highlights this. The robot can't just perform a pre-programmed lift. It has to constantly be aware of the patient's state.
How does it do that?
DryRec uses a combination of fisheye and depth cameras. It sees the whole environment and the patient at the same time.
And I think we need to mention the human motivation here. I was struck that 2 of the lead researchers, Professor Etsuko Kobayashi and Matsumura, got into this because of their own aging mothers.
Yeah. This isn't just an abstract problem for them. It's deeply personal. They want to create something safe and reliable for the people they care about.
And that personal stake, it seems to drive the need for precision.
It absolutely does. To learn how to touch a person correctly, all the training data for movement and force comes directly from watching skilled human caregivers do their jobs.
So then the critical question, how does the robot know it's using the right amount of force? How does it avoid causing pain?
That is the most critical detail. It's constantly predicting the pressure it needs to apply to, say, the shoulders or the knees. It uses its cameras and sensors to make a prediction, and then it compares that to the live pressure readings as it performs the action.
So it's an active feedback loop.
A constant prediction and correction loop, yes. It ensures the force is just right enough to be stable, but gentle enough to not cause pain.
So when you take a step back, what we're seeing is a path for robots to move from the lab into these incredibly personal, physically intimate roles, and it all hinges on getting that force estimation right.
It's a monumental leap. It leaves you with a pretty big question, I think. If robots can now handle tasks that require this level of, physical empathy, like safely repositioning a fragile patient, what's left? What level of human interaction that we all think is irreplaceable will actually be the last frontier for automation?